The important thing to remember is that the way that we understand logarithms is basically to convert the logarithmic form into exponential form. And the way that we undo the logarithm, the way that we go from log form to exponential form, is with the wave. That's how we make it happen. Specifically, we can think about we're undoing the logarithm with the wave. That's how we get rid of the logarithm, is this little raise equal to. So if you look here, the first thing to notice is that for the wave to work, your logarithm needs to be on the left. So they've given us 4 equals log base 5 of 625. First thing I'm going to do is rewrite this as log base 5 625 on the left equals 4. That's very important. So log needs to be on the left for the wave. So for this raise equal to. So once I have rewritten it, then I take my base and raise it to the 4th power. So that's going to look like 5 raised to the 4th power, and then that equals my 625. So we would say that our exponential form here is 5 raised to the 4th equals 625. So the same thing is going to happen here for this next example. First thing you're going to do is you're going to rewrite it with the log on the left-hand side. And then once the log is on the left-hand side, then you can do your raise equal. So you'll take 9, raise it to the 2nd, and then that is equal to 81. So our equivalent exponential form would be this 9 squared is equal to 81. That's what we would type in on the homework software. So same thing goes over here. Do not be intimidated by these negative exponents or negative numbers. Same thing, we're doing the wave. So it's going to be 6, raise it to the -2 equals the 1 over 36. And I do sometimes ask these questions on the test just because it is very important as you leave business calculus to always understand what those logarithms represent, and they represent an exponential format. The other thing that is very important to know in terms of logarithms are there are two very important logarithms. The first is the common logarithm, and then the second being the natural logarithm. So these logarithms are programmed in on your graphing calculator, scientific calculator. The important thing that I want you to know is that when you see just log, the base for that is 10. So nobody's going to write the base. They're just going to assume that it's understood 10. So again, when you see just log x, that base is understood to be 10. And the other logarithm is our natural logarithm. That's ln. And when you see ln, that base is understood to be e. So nobody's going to write the e. They are just going to assume as an educated person that you know that you're talking about base e. So again, to repeat, the understood base of just log, that has a base of 10. And then the understood base of natural log is e. And the reason why these logarithms are very important is because those are the logarithms that are by default programmed in on scientific and graphing calculators. So you'll notice that on your calculator you have right next to 7 and 4 you have this log and natural log, and you'll also notice right above the common logarithm, the log, there's a 10 to the x, and that's because your base is 10. And the same thing for this ln, right above it there's an e, and that is because your base is e. So you can kind of look at your calculator to figure out what the base is. Base of common log is 10, base of natural log is e. But those are very special logarithms that are going to be used in a lot of calculations.